Hi everyone, I am Dr. Peiris. So in this lecture I am going to show you how to graph stretch or compression in exponential functions. So first I'll show you what is the general form when there is a vertical stretch or a compression in an exponential function. Then we're going to discuss how to graph the vertical stretch and a vertical compression. So what is the general form? So the parent exponential function is given using this relationship f of x equals b of x. And if an exponential function has a vertical stretch or a compression, it is given using this equation. So basically the parent function is multiplied by a constant a. And depending on the value of the a, we're going to have a stretch or a compression. So if the magnitude of the a is greater than 1, the parent function is stretched vertically by the same amount a. If the magnitude of the a is less than 1, it is going to be a compression, a vertical compression by the factor of a. Since it is only a vertical stretch or a compression, the horizontal asymptote stays as y equals 0 as explained in the parent exponential function. The range is also stays same 0 to infinity compared to the parent function. I have a video which I explain how to graph this parent exponential function and how to obtain the horizontal asymptote as well as the range. So please visit that video if you are not familiar with how to graph these parent exponential functions. Now let's see a few examples. So first I'm going to show you a vertical stretch when the b greater than 1. So what is the value of the b here? B is 3. B is the value of the 3 and the vertical stretch is 2. So this vertical stretch is 2. So the first thing we are going to do is obtain the coordinates for the parent function. So the parent function is y equals 3 to the x. So let's obtain the parent function. So we substitute x values -1, 0, 1. I prefer to choose these values for the x to make the calculations easy on the exponential functions. You can choose any value you want, but choose at least 3 to learn how to connect the points on when you graph. So let's go and substitute these x values in this function. So 3 raised to the -1, which is 1/3. 3 to the 0, 1. 3 to the 1 is 3. Now what happened to this function? This parent function is multiplied by 2, which means the y values that we obtained for this part, y equals 3 to the x. These y values are multiplied by 2. So we need to multiply all the y values that we obtained in the parent function to obtain the given function. So we multiply everything by 2. So let's multiply these numbers by 2. So the original y values are 1/3, 1 and 3. Now we're going to multiply by 2 because this is a vertical stretch. So times 2, this is 2 over 3, times 2, which is 2, times 2, 6. So these are the new y values. Now is there any change for the x values? There is no change for the x values because this is only a vertical stretch. So something is happening to the values in the y-axis, but nothing happened to the x values. So the x values remain same as -1, 0, 1. And again, since it is only a vertical stretch, no change to the horizontal asymptote, which is at y equals 0. Now let's put these points on the graph to plot the graph. So the first one, -1, 2/3. -1, 2/3 is a value which is less than 1. Then 0, 2. Then 1, 6. So we can see that the function has been stretched. The values go up by a factor of 2. Make sure we keep the horizontal asymptote at y equals 0. So when you graph that, you don't cross the x-axis. So this is the given function f of x equals 2 times 3 to the x. And the range stays from 0 to infinity. It's the same range. compared to the parent function y equals 3 to the x. The next example, it's again a vertical stretch because it is a positive 3, so it's a vertical stretch, and now the value of the b is half, so which is in between 0 and 1. So we're going to have a decreasing function, but which is multiplied by a 3, that is making a vertical stretch. So again we do the parent function, which is 1/2 to the x. We find the x and y coordinates for that. So half x is -1, 2, half x is 0, which is equal to 1, x is 1, half to the 1 is half. The x values stays same, -1, 0, 1 in the given function because it's only a vertical stretch. Now to find the new y values for this given function, we multiply the values that we found for the parent function by 3. So all the y values are multiplied by 3. Y values are 2, 1 and half. We multiply these by 3. 2 times 3, 6. 1 times 3, 3. 1/2 times 3 is 3/2. The horizontal asymptote is same, y equals 0. So let's mark the points. -1, 6. The next one 0, 3. Then 1, 3/2. 1, 3/2. So the 3/2 is a value which is greater than 2. 3/2 is basically 1.5. So it's 1, 1.5. And we connect the dots. So you see this is a decreasing function because the value of the b is half. It's a decreasing function. Now the range is same, 0 to infinity. Now let's see how to graph the compressions, vertical compressions. So this is an example of a vertical compression. We can see the value of the a is 1/4, so which is less than 1. So that is why this becomes a compression. The y values are multiplied by 1/4. So the y value is going to decrease by a factor of 4. That's why we call these compressions. So this is the case where the b is greater than 1, b is equal to 2. So our parent function is y equals 2 to the x. Now let's obtain the y coordinate for the parent function. 2 to the -1 is 1/2. 2 to the 0 is 1. 2 to the 1 is 2. The x values remain same as these. The y values need to be multiplied by 1/4. So we multiply all of these y values by 1/4. Half, 1, 2. So these are the values that we found for the parent function. Now we multiply these by 1/4. It becomes 1/8. So we see that the y values decrease by a factor of 4. 1 times 1/4, 1/4. 2 times 1/4, which is 1/2. So the values become all fractions compared to the parent function. So that is why we call this a compression. The y values decreases. Now let's put the points. -1, 1/8. So it has to be very close to 0. And the next one 0, 1/4. So still it is less than 1. Then 1/2, 1.5. So this is how the points look like. All the points are less than 1. And then we connect these. So our horizontal asymptote is same, y equals 0, and the range is 0 to infinity. So this is how we do the vertical compressions. It's exact same procedure compared to the vertical stretch, but you will see that all the values are very small for the y coordinate. Next example, again it's a compression because a is equal to 1/2 and the b is 1/3. So let's obtain the x and y for the parent function 1/3 x. 1/3 minus 1, 3. 1/3 to the 0 is 1. 1/3 to the 1 is 1/3. The x values stays same, -1, 0, 1. Same x values for the given function. What happened to the y values? They are multiplied by 1/2. So we multiply these y values by 1/2. 3, 1, 1/3 are the original y values, then times by 1/2. Then we simplify. 3/2 half 1/6. So the first point is -1, 3/2. So 3/2 is 1.5. -1 to 1.5. And then 0 half. And then 1 comma 1 sixth. 1/6 is very close to 0. The horizontal asymptote is y equals 0, and the range is 0 to infinity. So this is how we do the vertical compressions and the stretch compared to the parent function. So it is always easy if you find the coordinates for the parent function and then think what happened in the given transformation. Does that affect to the x or to the y? And depending on that, you change the x and the y values of the parent functions. So that's all for today, everyone. Please subscribe to my YouTube channel, Dr. Peiris Classroom, as well as visit my website, drpeirisclassroom.com. I'll meet you again with more videos. Thanks for watching. Bye, everyone.